In this video, I want to tell you about a reason for a statement in a geometric proof that's very, very common, and it's called corresponding parts of congruent triangles are congruent. If you take the first letters here, we often abbreviate it as CPCTC. Here's an example of a typical proof that involves CPCTC. You'll notice that the thing that they're asking you to prove is not that some triangle is congruent to some other triangle, but that some angle is congruent to some angle, or that some line segment is congruent to some line segment. Now, even though there's no mention of triangles here, in the diagram there's clearly two triangles, and with this given information, it seems like we're really able to say something, which is that in this case, by SAS, side angle side, the two triangles ACB are congruent to triangle DFE. Now, they didn't ask you to prove those two triangles congruent, but we did it anyway, because once you've proved two triangles congruent, once you've established that some triangle is congruent to some other triangle, you now get to say that the other pieces that haven't been mentioned yet are also congruent. So we had three pieces that led us to the congruence, but the other three pieces, like angle C and angle F, are congruent, and side CB and side FE are congruent, and angle B and E, which is what they wanted us to prove, we now can say it, and our reason is corresponding parts of congruent triangles are congruent. The most important letter there is the middle C there, because that stands for congruent. So we've proven that two triangles are congruent, and then we are allowed to talk about the other three pieces that weren't mentioned yet. So this was one where we were finding that two angles were congruent. So there's only one given thing, and this is actually going to take 6 steps. Proving that A is congruent to C. Good idea to put a little question mark here. Don't mark them like they are congruent, because even though that's our hope, if you mark it with like an arc, it looks like you're already saying that you know they're congruent, which you don't. Now, there's only two triangles in this picture, so the plan is to prove that ABM, triangle ABM, and CBM are congruent. So let's get that happening. Because M is the midpoint. Oh, there is another piece of given information. Sorry. AB is congruent to BC. Now, as I was saying, because M is the midpoint, we can say that AM is congruent to MC. That's definition of midpoint. And side was given, another side was given. And in a picture like this, common to have this shared side reflexive. So MB is congruent to MB, reflexive. Now I can say for step 5, I can say the triangles AMB and A triangle AMB is congruent to triangle CMB. That's by SS. And now that I have the triangles congruent, it's pretty much always the step right after. You can say, because I've established these two triangles congruent, not only are the three pieces that I use to prove the triangles congruent, but the other three pieces are also congruent to each other, corresponding pieces, including angle A and angle C. So that's how this proof looks. So what we saw is one proof where we proved two angles were congruent, and one where we proved two line segments are congruent. The hardest part about these proofs sometimes is knowing which two triangles to prove congruent. Now, in this one, there only were two triangles, and in this one, there only were two triangles. But sometimes you have one with a lot of overlapping triangles, and it's not so clear which two we're trying to prove congruent. So here's a diagram, and we're being asked to prove that that line segment AE is congruent to line segment AC. And the problem in this one is that there's a lot of different triangles. For instance, there's these little skinny triangles, DCB and DEF. Maybe those are the two we have to prove congruent. There's these medium ones, DBA and DAF. And there's the large ones, DCA and DEA. Now, one thing you can do is look at what the given is. They tell us DC is congruent to DE, so it kind of... Well, those DC are parts of the small triangles, the DCB and DEF triangle, and also parts of the really large ones, the DCA and DEA. So that's not so much information. We're also told that Z and Y are equal. Sorry, Z and W, I mean. Now, those are part of the real small triangle. So maybe we have an angle and a side. Maybe there's an angle-side angle or a side-angle-side going on with proving those small triangles congruent. They also tell us X and Y are congruent, which are parts of these medium-sized triangles. So it's kind of confusing, like, where do I go with this? Well, you could look at the picture and see, like, I'm pretty close to proving those two small triangles congruent. The problem is I don't know any more information. A good hint for you comes from looking at what it is you're trying to prove. AE, so we're trying to prove that this big line segment is the same length as AC, and those are definitely parts of the large triangles. So now I know my plan is going to be to prove the large triangles are congruent. And let's see how that goes. So here's all my given. And I already have two... since I'm going for the large triangles, I notice I've got this shared side in the middle of both. So that seems like that's going to have a good chance to be part of it. AD is congruent to AD reflexive. So now I have two sides. I have this side and this side going with this side and this side. What I'm missing is the angle. And not just any angle, it has to be the so-called including angle, included namely this angle and this one. And I'm not told that they're congruent, but I'm told Z and W are congruent and that X and Y are congruent, which means the sum of Z and X should be congruent to the sum of Y and W. And that is the key to this. It's all going to happen in one big step. Angle, basically I'm taking these two lines. Angle X plus angle Z is congruent to angle Y plus angle W, comma, or together it's angle CDA is congruent to EDA. And that is the missing angle that I needed in between the two sides that were congruent. So now the last two steps, this one's going to be the addition property. Now we're going to finish out with an SAS and a CPCTC. So the SAS is saying that triangles DCA and DEA, triangle and now that I have that, the final step, that's SAS, the final step is the thing we were trying to prove all along. AE is congruent to AC. CPCTC. So there's a typical two-column proof that we know it's going to need CPCTC because I'm not asked to find congruent triangles, but find two triangles congruent and then go one step further. So this one was a 7-step. And this is a good question because it's kind of confusing with all the different possibilities of which triangles you might be trying to find congruent.